Hi, welcome to the lab experiment for the course number KIG2011. So today we will be talking about heat conduction experiment U2, and I will be going with you through the whole experiment process and understand what is it all about. So first of all, heat conduction experiment is to study the thermal conductivity coefficient governed by the theory of Fourier law. So as I go along with the procedure, I will be discussing with you how the experiment is conducted and how the data is set and how we can use this data to interpret what is thermal conductivity of specific material. Alright guys, so this is the apparatus setup for the heat conduction U2 experiment under the course code KIG2011. Before we start this procedure, we need to understand the apparatus. Then we need to know what is what and how to make it work. So if we come closer, we can see here that we have multiple options. The first one here is the power supply, the switch on and off button to turn on the whole apparatus that will control the power and take in the measurement. So here is a thermometer connected to this brass apparatus that I will talk about it in a bit. But now going back to this main apparatus, here we have the power control button, so we can actually see to control the power input towards the other device that I've just shown earlier. And here is the main power supply cable that we don't really have to do much with now. Just make sure that it's connected. Alright, moving on from the main power supply apparatus towards the brass disc. So here we can see the brass disc with the 6 inputs. So basically the brass disc is at an outer diameter of 55 millimeter and inner radius of 4 millimeter with a length of 3 millimeter. Now we have at the middle of this brass disc we have a thermistor sensor that is attached to its center, and along its axis with a 10 millimeter interval. Now of course we have an electric console used to control the heat intake as well as a water supply connected to it, flowing in and out of it to maintain its coolness and avoid overheating. Before starting the experiment, we need to take a couple of safety procedures to ensure that the apparatus is running smoothly. So the first thing first is that we have to open the water flow for the cooling of the brass disc device. So we open it slightly until the white points meet, and after that we go to the main switch of the main power supply device and turn it on from the first socket, and secondly from this. After ensuring that the water flow and the electric supply are open for this apparatus, we go ahead and switch on the main button. And here we can see the device has turned on successfully. Now the next step would be turning up the power supply button here towards the given amount of power needed from the lab experiment or the lab sheet. So we can see here for our initial value we have 10 watts going in to the main brass disc. Alright, so after turning it on and adjusting the power input and waiting for at least 5 minutes for the whole apparatus to stabilize, now we are going to take the measurements from the points here in the brass disc. So if you come closer, we have the clip here go to the first point, and then the pin here goes inside. So now the first point with the temperature is around 31.7. So after taking the measurements from the first point, we go ahead and we take for the second, the third, the fourth, the fifth, and the sixth for our initial given power input. So after taking the 6 measurements for this power input, we go ahead and adjust it to the next power input given in our lab sheet. Alright, so after taking the measurement for the 6 points input for each power supply given in our lab sheet, we go ahead and finish the experiment. So first thing first, what we do is that we go to the power input and then turn it off to 0. After that, we switch off the power switch. Then we go ahead and turn it off from here and here as well. You can see here that the device has turned off successfully. Now, after a while, we close the water tap to ensure that there's no water is wasted. And this concludes the heat conduction U2 experiment for the course KIG2011.